Hiya. So today we're going to be looking at the WJEC paper, and it's the higher level paper one, which is the non-calculator paper. So with the Welsh board you get, and some of this will be the same as the first, I think 7, 8 questions. I think it's actually till question 11 is the same as the end of the foundation, and then more of the questions are the same as the intermediate paper. So we've got to circle the best approximate answer here. So let's just make sure we've got right with something. Okay. And here we've got 596, and because it's asking for an approximate, you can round as much as you like. So we're going to round that to 600. We're going to round the 38.2 to 40, and I'm going to round that to 10. So I'm going to get 600 over 50. 60 over 50, which is about 12. So that's our approximation for that calculation. Right, now we've got a number is increased by 4% of its value. We're told it's done 7 times. So every time it's got 7%, 4% bigger, sorry, then another 4% and another 4%. So whenever we increase something, so in terms of percentages, when you see increase, it means you're taking the full amount, the 100%, plus an additional 4%. So that's 1.04. And we're now told it's 7 times. So it's going to be 1.04 to the power of 7, because you're going to keep multiplying it. Okay, so then we've got a fraction, 4/5 divided by 1/4. So it's a division of a fraction. So division is when you change it to a times, you change it to a multiply, and you flip. So it's the kiss and flip. Sorry, my phone rang in between. So we've got 4/5. We're going to change the divide to a times, and we're going to flip the second one over. So we'll get 4 over 1. So 4 times 4 is 16. And we've got 16 over 5. Now that's more than 1. So how many 5s in 16? Well, we've got 3. And so we can immediately go there. 3 and 1/5. Okay, so the next page. Let's scroll that up. We've got a Venn diagram. We've got 30 rugby supporters travel to Cardiff on a coach. They decide to investigate how many of them can sing one or both of the songs. I'm not going to try to pronounce that. 12 say they can sing both songs. Both tells you that it's in the middle. So we've got 12 in the middle. 18 can sing Bread of Heaven. So this whole circle here has to equal 18. So this entire circle here. We already have 12 in there. So that's got to be a 6. And 5 can't sing either. So there's 5 on the outside. But in total, we've got 30. So we can do 30. So the whole box has to add up to 30. So we can do 30 minus 5 minus 6 minus 12. And that's going to give us a 7 there. And we've completed the Venn diagram. Then it tells us one of these supporters is chosen at random. What is the probability that they can sing the Welsh song? Okay, so how many people can sing that? So we know that we've got 7 and 12. So altogether we've got 19 people out of the 30. So the answer would be 19 over 30. Scroll that up. We've got expand and simplify. So here we are, we're going to be opening out some brackets. So we've got x, and then in a bracket, we've got 5x minus 2. So when we open that out, we get x times 5x to give us 5x squared, x times minus 2 to give us minus 2x. Now be careful with the next one. Outside the bracket, you've got minus 3. So everything inside the bracket is being multiplied by minus 3. So you've got minus 3 times x squared to give you minus 3x squared. minus 3 times minus 2, which is going to give you plus 6. And then you've got minus 3 times 7 to give you minus 21. And that's going to simplify to, I've got 5x squared. So I put all the things that are the same together. So those two are the same. Those are the x's. And then you've got the 21. So you've got 5x squared minus 3x squared, sorry. I feel like a sneeze is coming, but it's not quite there. Anyway, 5 minus 3x squared to give you 2x squared. Minus 2 plus 6 to give you plus 4x. And then you've got minus 21. So that would be simplified in the most simplest form, which I think is quite a nice form offset. Right, part B gets you to solve 22 minus f over 3 equals 6. So you cover up, if you like, the bit that has the unknown in it. So the 22 minus f has the unknown. So something divided by 3 equals 6. So your first step is going to be to multiply both sides by 3. So when I multiply the left by 3, I get, oh, I'm not sure what's happening on TikTok, sorry. So when I multiply the left by 3, I get 22 minus f. And when I multiply the right, I get 6 times 3, which gives me 18. And then if I want to get f on its own, I've got to move either the f to the other side and make it positive, but if you're happy dealing with negative numbers, so you essentially can go straight to the answer. You can say 22 minus something equals 18. Now that something has to be 4. Right, let's scroll up. So we've got a fair-sided dice is thrown twice. What is the probability that a 3 is thrown on both occasions? So it's fair. The important thing about the fair is that it's 6-sided, that a probability of getting anything is 1/6. Now we've thrown it once and got a 6. And if you remember from things I've said before with probability, when you want and is always times. So or is add and is times. So we want a 3 and a 3. So it's times a 6 to give you 1 over 36. All right, part B. A company has, offices. Okay, so I think here, no, you don't need a protractor. Has offices in 4 different places. As you can see, I'm not even going to try to pronounce any Welsh. The pie chart shows the fraction of the committee members that come from each office. There is an equal numbers in Newtown and something Vale. A member is chosen at random from this committee to be the chairperson. The probability is shown in the table. So it's quite clear to see this as half of the circle. And hopefully, because you can see this 90 degrees, so this square thing means that it's a 90-degree angle. It means that all of this is a quarter of the circle. So therefore, the number that's going to go here is a quarter. And then how much is left? So if you've taken away a half, taken away a quarter, you're left with 1/4. But what have you done to that quarter? You've split it in 2. So when you split a quarter into 2, you get an 1/8 because you're halving the bottom. So the 4 would have been on the bottom. 4 times 2 is 8. Then it says, what is the probability that a chosen member, so if I clear that and scroll that up, so you can see the question. So we had a quarter, an 1/8, an 1/8. So what is the probability that a member chosen as a chairperson works at either, so L or E? I'm just going to call it by the first letters. So or, remember we said was add, right? So now we can see what we're going to add together. We've got to add up this number and this number. And the key there is it's the word or. So the word and would be multiply, the word or would be add. So we've got a half plus an 1/8 which you can make the denominators the same. So you want to make that into an eighth. So to go from 2 to 8, you're timesing by 4. So the top will be 4. So you end up with 5/8. Okay, let's go to the next question. So we've got standard form. Remember, it's non-calculator. And we've got to calculate the value of 2 times 10 to the power of minus 4 multiplied by 7.8 times 10 to the 9. So the first things we're going to do is just take the numbers. So forget the indices and the powers. So we've got 2 times 7.8. So remember, when we multiply decimals, we pretend like the decimal's not there, and we just multiply them as normal. So 2 times 78. Double timesing by 2 is just doubling. So we can double the 70 first, which gives us 140. Double the 8, which gives us 16. And when we add them together, we would get 156. But how many numbers are behind the decimal place? There's only 1. So it's going to be 15.6. Then we're going to take the indices. So we've got 10 to the minus 4 times 10 to the 9. Indices, when you multiply, it means you add the bits on the top. So minus 4 plus 9 is the same as 9 take away 4, which is 5. So we know we've got 15.6 times 10 to the 5, but we've still got a problem here. That's not in standard form. And the reason it's not in standard form is because this number here has to be between 1 and 9. So that number's too big. So how do we make that into standard form? We want to make that 1.56, and then we're going to have to add a 10 because we would have need to multiply up. Calculate the value of 3.9 times 10 to the 8 over 3,000. And it wants the answer in standard form. So the best way to do that would be to change this potentially into standard form. So what would we have? We've got 3.9 times 10 to the 8. And we're going to divide that by, because that's all that means, 3 times 10 cubed, because that's what we've got on the bottom. So again, we're going to take the numbers separately. So we're going to say 3.9 divided by 3. So 3 divided by 3 is going to give you 1. 9 divided by 3 is going to give you 3, so you get 1.3. And then you've got 10 to the 8 divided by 10 to the 3. So the same way it was adding for timesing, it's taking away for dividing. So 8 take away 3 is 5. So our final answer is 1.3 times 10 to the 5. Okay, and the last question here is to factorize. So we look at the numbers, 12 and 3. Is there a common factor? Yes, there is, 3. Then we look at the x's. X and x squared, what's the smallest amount that we've got there? X. And then we can see a y, but it's only one of them, so we can't take it outside of a bracket. Then we've got to open the bracket. 3 times what gives you 12? Or 3 times 4 gives you 12. X times something is going to give you x squared. So that's going to be x. And then we're going to put the y there as well. So we get 3x, open brackets, 4x plus y. Okay. So if you have a look at, that was question 6, okay. So question 7. Calculate the size of the angle X in the diagram below. And it's telling you it's not drawn to scale. So if we have a look, the bit that we know is what kind of shape is that? It's a 4-sided shape inside a circle. So it's called a cyclic quadrilateral. God, I really can't talk today. And what we know about them is that the opposite angles of that 4-sided shape add up to 180. So if the angle ABC is 71, that means that the angle ADC must be 109. So ADC, so this one here, is 109. And we know that angles in a triangle always add up to 180. So that means x must be the same as 180, take away 26, take away 109, which gives you 45 degrees. Okay, and if you had to do a little division, take away some on the side, or however you needed to do that, that would have been fine, but that's as much working as you need to show. Okay, so we're not going to do 8 because it's a drawing one, and we'll maybe do them later using the visualizer so I can show you how to draw it, but we'll move on to question 9. Okay, so in this question, you'll be assessed on the quality of your organization, communication, and accuracy. So these are the ones where the marks suddenly matter in how you lay it out. So in total, it's 7 marks. And we're going to prove that AX equals BX. So we're trying to prove that this line here, this line here, AX is the same as BX. So that's what we're trying to prove. So let's just first of all go step by step and try work out what we know. Right. We're told that BX equals BC. So we're told that this line here, so BX, which is in pink, also is the same as this line here. So we know straight away that's what kind of triangle. So that's called an isosceles triangle. So these two lengths are the same. So those lines represent them being the same. Right, so if they're the same, we know what we call the base angles are also the same. So that means, so I'm just at the moment trying to think of all the things that I know based on the information that they're telling me. And let's write that in words because we're getting the marks for it. So we're going to say the angle BXC equals 80 degrees because it's the base angles of isosceles, I can't spell, I think I got that right, triangle. Okay, so we've got something. And that means we can find AXB, for example. So we can find this angle here because we've got a straight line. So we know angles on a straight line add up to 180. So we can say AX, it doesn't matter, you can either write angle like I have up here, or you can write it like that. So AXB equals 180 minus 80, which equals 100. And because angles on a straight line add up to 180. Add to 180 degrees. Okay, right. I'm going to write on the side so I don't lose it off the page. And then finally, what else could we do? So we know this angle's 100, we know that's 40, which means we can work out this angle here. So we can work out ABX is 40. So ABX equals 40 degrees, and that's because of angles in a triangle. Triangle, add up, you would write that nicely than I have, add up to 180 degrees. And so now, how does that prove that those two lines that we saw must be the same? Because we've created another isosceles triangle. Because if you have a look, these two base angles are the same. So this length is the same as this length. So your final sentence would be that AX equals BX because base angles are both 40 degrees. And you could write isosceles triangle, and that would get you your 7 marks. Right, so question. So like I said, the drawing ones will come back to when I can do it on some paper for you. Right, so we've got Y is directly proportional. So remember, you can see the words directly proportional, and immediately you're going to write equal. So you see the word directly proportional, directly proportional in any question, and your brain is going to immediately go, I can't spell there again, Mr. P. Anyway, directly proportional, and you're going to write K times. Inversely proportional, and your brain is going to do, so if it said inversely proportional, which one, this one doesn't, is going to do K over, so K divide. So we can see Y is directly proportional, so equals K times the square root of X. So we see that directly proportional coincides with equals K times. And so what are we going to do with that? We're going to sub in the numbers that we have. So we know that Y is 30 equals K times the root of 36. The root of 36 is 6. So K times 6 is 30. So K is 30 divided by 6, which is 5. So we know that Y equals 5 root X. We don't need that times sign. If you'd written it in, you wouldn't lose marks. Now it's saying use your table, use your expression to complete the table. So here we know what X is. We're told X is 49, so we can put that in there. So Y equals 5 times the root of 49. So the root of, what's the root of 49? So we should know that. So 5 times 7 is 35. My brain went blank for a second. And here we're told the Y value, which is 40, equals 5 times root X. So we want to get root X on its own. 40 divided by 5 gives you, so you're going to end up with 8 equals root X. How do you get rid of root X? So what's the opposite of rooting in it something? Is squaring it. So we square the 8 and we get 64. Right, so let's have a look at the next set of questions. Right, so we've got lots of triangles here. Okay, there's lots of triangles, and you're supposed to identify things that are definitely congruent. Okay, so remember you've got side, angle, side, or side, side, side. That's what we're looking for. So if I look at that, I hopefully can straight away see, I don't know whether you can see, is that D and E have all the same numbers on the sides. 3.9, 3.9, they've just been written in different places. So angle D is congruent to E, and all you need to write as your condition for congruency is SSS. You could write 3 sides if you wanted. And then it's asking for the next one that is as well. And if we have a look, I would look for things that I can see are the same. And you can see you've got an angle, and either side of it, you've got 3.9 and 4.4, 65, 3.9 and 4.4. So angle A and G, and the reason that it's congruent is side, angle, side. So that's quite a nice question, because that was they were quite obvious. So it was quite clear there. Okay, question 13. A ball is thrown upwards from a height of 1 meter. After t seconds, the height above the ground is given by. Show that the time taken to reach a height of 4 meters satisfies that equation. So we want to reach a height of 4 meters. So we're replacing the h, which is the height, with 4. Someone's asked me for the previous question, what does K stand for? K is just your constant of proportionality. So the thing that is increasing by each time. So if you think of it like proportional means like a straight line gradient. So it would be like the gradient of that straight line. So how much something's increasing by each time. Sorry, back to this question. So you've got 4 equals 1 plus 8t minus 5t squared. What you're going to do is you want to move that all to one side, so it looks like that. So we'll get 5t squared minus 8t plus 3 equals 0. And it's only 1 mark, so that's sufficient. So now we want to be able to factorize this. So it's one with a number in front of the t. So remember, it's always easier to borrow the number to the 3. So we're going to do 5 times 3. So we're going to get t squared minus 8t plus 15. We're going to factorize that first. All right, so we'll get t and t. And hopefully you see that that's going to give you 5 and 3. And it's going to be minus for both of them. 5, 6, 7, 8. Yeah. And then you've got to give the 5 back. So you get 5t minus 3, 5t minus 5. This one is already in its simplest form. This one you can divide by 5, and you've got your factorization. So that equals 0. Now, each of those brackets can equal 0. So you can have 5t minus 3 equals 0, or t minus 1 equals 0. So t equals 3 over 5, and t equals 1. Then the question says to interpret your answer in the context of the question. Now, why have you got 2 values? So if you think about it, you've got your ball, and it's being, I probably shouldn't have done that. Okay, so this is your height. This is the ground. It's being thrown up from 1 meter above the ground. So it's doing something like this. So there's going to be 2 points where it's going to be 4 meters above the ground, isn't there? There's going to be the first one on the way up, which must be the t equals 3/5. And then there's going to be the one on the way down. So what it wants you to say is there are 2 different values representing, I don't know, the way up and the way down. The way up and the way down. Right, so let's do clear. All right, so we're going to do a few more questions. So we're probably going to do 2 more of these questions. In total, in the paper, there are, I think, 18 questions. Okay, well, we might even be able to get through the rest of these then. Right, so circle the correct answer for the following statement. So you've got 9 to the power of 3 over 2. So 9 to the power of 3 over 2. So your indice rules tell you the number on the top is cubing it, but that's going to make your number really big. When you have a fraction, so if you have anything to the power of a half, is the square root. So what this is actually is 9 to the half, and then you can cube it. You can split that 3 over 2 out. So to the power of a half means to take the square root, which would give you 3. 3 cubed is 27. Okay. Then we've got 10,000 to the minus 1 over 4. So remember, anything to a fraction is taking, in this case, the 4th root. The minus tells you have to flip it. Now here it's not a fraction to flip, but you imagine any whole number is over 1. So when you flip it, it's 1 over 10,000. And so we can get rid of the minus to the power of a quarter. Now when we do something to the power of a quarter, we take the square root, and then we take the square root again. So we're taking the square root once and the square root twice, which is giving you a 10th. Because 10 times 10 gives you 100, 100 times 100 will give you 10,000. Okay, so your answer there is a 10th. Okay, question 15. So express 0.245 as a fraction. So what that is, remember, so we say let n equal 0.2, and the 4 and the 5 are the ones with the dots on. So it means this. Now the whole point is you need to keep multiplying till something after the decimal place is the same, but you will keep multiplying by 10. So if I do 10n, I get 2.4545. Okay, but if I do 100n, I get 24.54. 5454, and that's not the same. What you're looking for is something to be the same after the decimal place. So at the moment, that's not the same as this. So those are not the same, so we can't use that. So we times it once more. Oops. So n is going to give you 245.454545 and so on. So now you can see that this is the same as this. So if I take this and I take it away from this, everything after the decimal place is going to disappear. So 1,000 minus 10 gives you 990. So you get 990n. And then you've got 245 minus 2. Thank you. Sorry, I think that was a delivery. So you've got 245 minus 2, which gives you 243. So n is 243 over 990. So let's do the last question. And we're going to expand and simplify. So we've got to expand the brackets here. So what we're going to do is 8 times 5, and that gives you, so 8 got distracted. 8 times 5 is 40. Then we've got 8 times root 7. So we get 8 root 7. We've got minus 3 root 7 times 5 to give you minus 15 root 7. And then you've got minus 3 root 7 times root 7. So this is where you've got 3 root 7 times root 7. So we know it's a minus. So root times a root is always itself. So root 7 times root 7 is 7. Root 100 times root 100 would be 100. So it doesn't matter. So we get 7, and then we're timesing it by the 3 to give us 21. 40 minus 21, so 40 minus 20 is 20, minus the additional 1 is going to give us 19. And then we've got 8 minus 15 to give us minus 7 root 7. So that's question 50. Okay, let's have a look at question 16. So 16 is drawing something accurately. Like I said, we'll do all the drawing ones at another point, and then we might actually get through it. Let's have a look at question 17. At a children's party, the children play a number of games. The winner of each game chooses a ticket for a prize at random for a box. The ticket is not returned. So that's the important bit of information there. So we're told the ticket is not returned to the box. At the start of the party, there are 12 prizes available. 1 book, 3 key rings, and 8 pencils. Find the probability that the winners of the first 2 games choose the same type of prize. So that means, well, they definitely both can't get books because there's only 1 book, so we don't even need to worry about that. So either they have a key ring and a key ring, so if I use the words, or a pencil and a pencil. So remember, the ands are going to be replaced by a multiply sign, and the or is going to be replaced with an addition sign. So to get a key ring is going to be 3 out of 12. Now we've taken 1, it's not returned, so there's only 2 left, and there's only 11 things left. Or, which is plus, a pencil where there's 8 out of 12, and then once we've taken it out, there's 7 out of 11. Now these go in brackets using like our bond mass rules. So we've got 3 times 2, and when you multiply fractions, you multiply the top and you multiply the bottom. So 3 times 2 to give you 6, 11 times 12 to give you 132. Then you've got 8 times 7, so 8 sevens, which gives you 52. And then when you add those up, got that right? Sorry, my final answer is not agreeing with the final answer I have here. So 56 over 132. Okay, so I think there's a problem with the mark scheme here. This is definitely right. 56 plus 6 gives you 62 over 132. Okay, so that's the probability that the winner of the first 2 games chooses the same prize. After the winners of the first 3 games have chosen their prizes, find the probability that the ticket for the book is still in the box. So we're going to say The winners of the first 3 games have chosen their prizes. So that means the book hasn't been picked. So instead of out of 12 things, there's still 12 things there, but only 11 have been picked. And then the second person picks, and now there's 10 things that don't include the book out of 11. And then there's 9 things that don't include the book out of 10. So then we're going to do 11 times 10 times 9. So 9 times 11 is 99, times 10 will give you 990. And we can do the same thing on the bottom. 12 times 11 is 132, times by 10, you add the 0, so 132. Now you could cancel that down, and it actually gives you 3/4. But if you didn't cancel it down, you don't lose any marks because they don't ask for it in the simplest form. And the last one is also a enlargement. I think it's one where you need. So what we're going to do is have a look at the last question. Okay, so we'll just have a look at this bit of this question. So we've got a sketch for y equals cos x. So this is, level 9, grade A stuff. And you've just got to think about it. So it's told you cos 21. So you think, where's 21? Well, 21 is somewhere between 0 and 90. So 21, for example, could be here. And they're telling you that's the same as 0.9336. And they're saying to you, write down everything that's the same as if you had minus 0.9336. Okay, so they're telling you this is 21. Now, what you notice about this is it's all symmetrical. So what you should be able to see is the space between things is the same. So what spaces here are the same? So if you think of that curve, this space here, we can see is the same as this space here. And if you were to flip that round, this space here is the same as this space here, even though I haven't drawn it particularly accurately. So if we said that, we can find out this space here. So what space would we have here? What is 90? So we would do 90, take away 21. So you'd have 9, you'd have 69 here. And that's going to be the same as this space here and this space here. So 90 plus 69 gives you 159. So your values for x would be 159 or 201 degrees. So I hope that makes sense. That's the little bit. Oh, I hope that makes sense. That's the much trickier bit. Okay, so I hope that was useful. I will do the other, I think there were 2 or 3 questions which require me to actually draw on a bit of paper, and I can connect it to the visualizer and show you those. But that's essentially the entire of the non-calculator paper. I will not be around tomorrow or next week in the day because it's Easter tomorrow and I'm running a revision class, but I'm going to try do some stuff on the weekend, and I will try pre-record stuff to put up on YouTube. So, and then after the Easter week, I'll be back and we'll do something twice a day again.